Next is theorems on symmetric and skew symmetric matrix. Symmetric and skew symmetric matrix. Theorems on symmetric and skew symmetric matrices. ಅಲ್ಲ ನಮ್ಮ ಬಾಯಲ್ಲಿ ಕೇಳಿಸುತ್ತಾರೆ ಬರ್ಕೊಳ್ಳಿ ಅಂತ ಬರ್ಕೊಳ್ತಾರ ಬೋರ್ಡ್ ಮೇಲೆ ಬರೀಬೇಕಾ? Take on theorem number 1. Theorem number 1. For any matrix capital E, for any matrix A, comma, A plus A transpose is a symmetric matrix. A plus A transpose is symmetric matrix, and A minus A transpose is a skew symmetric matrix. Is a skew symmetric matrix. This is the definition of theorem number 1. For any matrix A, show that A plus A transpose is a symmetric matrix. A minus A transpose is skew symmetric matrix. Definition is A is symmetric. Definition is, don't take down. A is symmetric. A transpose is equal to A. Definition. A is said to be symmetric. A transpose is A. A is skew symmetric. A is skew symmetric. Definition is A transpose is minus A. This is the definition of symmetric and skew symmetric matrix. See, I have to show that A plus A transpose is a symmetric matrix, means its whole transpose must be equal to A plus A transpose. First I will take let B is equal to A plus A transpose. I have taken this as B. A plus A transpose is B. See, to show that B is symmetric matrix, we have to show that B transpose is equal to B. I have taken A plus A transpose as B. To show that A plus A transpose is symmetric, I have to show that B transpose must be equal to B. Take transpose on both sides. B transpose is A plus A transpose whole transpose. Take the transpose on both sides. Take the transpose on both sides. See here, I have done problem based on this one. A plus B whole transpose is A transpose plus B transpose. In my last class, I have done problem based on A plus B whole transpose is A transpose plus B transpose. On the same line, this can be written as, on the same line, this is A, this is B whole transpose. This can be done as A transpose plus A transpose of whole transpose. This is A, this is B. A plus B whole transpose is A transpose plus A transpose of A transpose. Same properties of scalar properties of transpose. A transpose of whole transpose is A. I have given this one in properties of symmetric matrix. Therefore, B transpose is equal to A transpose plus A transpose whole transpose is A. Therefore, B transpose is A plus A transpose. Therefore, B is said to be symmetric. B transpose must be equal to B. Therefore, A plus A transpose. B is said to be symmetric if B transpose is equal to B. B is nothing but A plus A transpose. Therefore, A plus A transpose is symmetric matrix. We have shown that B is nothing but A plus A transpose is a symmetric. See here, B is said to be symmetric, B transpose is B. B is said to be symmetric, B transpose is equal to, this is nothing but B. If you want, you can take down this as B. A plus A transpose, we have taken as B. B transpose is B means, therefore A plus A transpose is a symmetric matrix. See, in the second case, I have to show that A minus A transpose is a skew symmetric matrix. You take let C is equal to A minus A transpose. Let C is equal to A minus A transpose. Take transpose on both sides. C transpose is equal to A minus A transpose whole transpose. Take transpose on both sides. We know that A minus B whole transpose is A transpose minus B transpose. This is A, this is B. A minus B whole transpose can be done as A transpose minus B transpose. Therefore, this is nothing but C transpose is A transpose minus of A transpose whole transpose. This is A minus B whole transpose is A transpose minus B is nothing but A transpose of transpose. But A transpose of transpose is nothing but A. C transpose is A transpose minus A. A transpose whole transpose is nothing but A. Take out minus common factor. If I take minus common factor, it becomes A minus A transpose. Take minus common factor, A minus A transpose. Therefore, C transpose is equal to minus E. Therefore, C is nothing but A minus A transpose is a skew symmetric matrix. Is a skew symmetric matrix. Is a skew symmetric matrix. C is nothing but A minus A transpose. It is a skew symmetric matrix. Usually in the examination, they will ask any one of the theorem for 3 marks on symmetric matrices or skewed symmetric matrices or transpose of a matrix. 3 marks question from this chapter: symmetric or skew symmetric or transpose. 3 marks question. Below this theorem you write, note, every square matrix. These are given already. Once again you take them. Every square matrix A. Every square matrix A can be expressed as sum of symmetric and skew symmetric matrix. Sum of symmetric and skew symmetric matrix. That is A can be written as half into A plus A transpose is symmetric minus half into plus half into A minus A transpose. This is one of the important results. Plus is A plus A transpose is symmetric. Just now we have proved A minus A transpose is symmetric. Therefore, every square matrix can be written as sum of symmetric and skew symmetric matrix. Please remember this result. There will be a problem for 3 marks based on this. Every square matrix can be expressed as sum of symmetric and skew symmetric matrix. Take on the problem. If A transpose is equal to -2, 3, 1, 2 and matrix B is -1, 0, 1, 2, find A plus 2B, A plus 2B whole transpose. See, in this problem you have to calculate first A plus 2B. A transpose is given, you have to calculate A. A is nothing but interchanging of rows and columns. A is nothing but A transpose is this one. A is nothing but interchanging of rows and columns. Write rows as column, column as rows. This is A. If A is given, interchanging A, rows and columns, you get A transpose. First we calculate A because in the question we need A plus 2B. Left hand side you write A plus 2B. Replace for A by this matrix. A is -2, 1, 3, 2 plus 2 into A plus 2 into B is nothing but -1, 0, 1, 2. This is A plus 2 into B. Second one is we are multiplying this matrix by 2 means multiply each element by 2. Take multiply each element by 2. Therefore A plus 2B is, write A as it is -2, 1, 3, 2 plus. This is scalar multiplication of a matrix by 2. Multiply each element by 2. 2 into -1 is -2. 2 into 0 is 0. 2 into 1 is 2. 2 into 2 is 4. Next is we are adding the two matrices. You have to add the corresponding elements of the two matrices. Therefore A plus 2B is, add the corresponding elements. For -2 corresponding elements is -2. -2 plus -2. Next 1 plus 0. Next 3 plus 2. Next 2 plus 4. After simplifying you get -4, 1, 5, 6. This is A plus 2B. Question is, we have to calculate A plus 2B transpose. Therefore, A plus 2B whole transpose is equal to, this is A plus 2B. To calculate its transpose, interchanging the rows and columns. This is -4. Write rows as column, column as rows. A plus B 2B whole transpose is -4. This is A plus 2B. Its transpose means interchanging rows and columns. Final answer is -4, 5, 1, 6. For the matrices A and B. For the matrices A and B. For the matrices A and B, verify AB whole transpose is equal to B transpose A transpose. See, in properties of transpose, the last property is AB whole transpose is B transpose A transpose, where A is equal to, where A is, matrix A is 1 minus 4 3, 1 minus 4 3, B is minus 1 2 1. This is AB. First I have to calculate AB, then transpose, B transpose, A transpose. A is given. First to calculate A transpose. Write rows as column, column as row. 1 minus 4, 3. This is 3 cross 1. This is 1 cross 3. Transpose. Reverse. First to calculate A transpose by interchanging of rows and columns. Next, B transpose is, this is 1 row, 3 column. B transpose is, write rows as column, minus 1, 2, 1. B transpose. This is 3 cross 1. 3 rows, 1 column. Calculate AB first. First you calculate AB. Write A, it is a column matrix. 1 minus 4, 3 into B is minus 1, 2, 1. This is 3 cross 1. This is 1 cross 3. After multiplying you get 3 cross 3 matrix. First one is 3 cross 1, 3 rows, 1 column. B is 1 row, 3 column. You should get 3 rows, 3 column. You should be very careful. While multiplying any two matrix, please write the order and you should know what is the after multiplication. AB is first row, first column, 1 into minus 1. First row, first column got over. Next, first row, second column, leave a little bit of space in between each element. First row, first column, leave a little bit of space in between two elements. First row, second column, first row, third column. While multiplying, you should be very careful. You will definitely make mistake if you don't write the order of the two matrices. This is the multiplication of first row with all the 3 columns. First row with all the 3 columns. Next, multiplication of second row with all the 3 columns. Minus 4 into minus 1. First row, second row, first column got over. There is no element below this one. Next, minus 4 into 2. Second row, second column. Minus 4 into 1. Next, third row, first column. 3 into minus 1. 3 into 2. 3 into 1. First row, first column, first row, second column, first row, third column must be written in first row. Second row with all the 3 columns, second row. Third row with all the 3 columns, you should write it in third row. Therefore, AB is equal to, you should get a 3 cross 3 matrix. 1 into minus 1 is minus 1. 1 into 2 is 2. 1 into 1 is 1. Next, minus 4 into minus 1 is plus 4. Minus 8. Minus 4. Next, minus 3. 6. 3. This is AB. We have to verify AB whole transpose is equal to B transpose A transpose. We have to verify. AB is this one, write its transpose. Minus 1, 2, 1. 4 minus 8 minus 4. 4 minus 8 minus 4 minus 3, 6, 3. It's transpose. Write transpose. This is matrix is AB, write its transpose. Is equal to, replace B transpose by this matrix. B transpose is minus 1, 2, 1 into A transpose is row matrix 1, minus 4, 3. Again while multiplying 3 cross 1, 1 cross 3, after multiplying you get 3 cross 3 matrix. This matrix is AB, write its transpose. Transpose means interchanging of rows and columns. This is multiplication of the two matrices. Transpose of this matrix is write rows as column, column as row. Minus 1, 2, 1. Write rows as column. 4, minus 8, minus 4. Minus 3, 6, 3 is equal to. This is multiplication. First row, first column, first row, second column, first row, third column. It must be written in first row. It must be written in first row. Minus 1 into 1. First row, first column got over. Minus 1 into 1. First row, first column got over. Next, leave a little bit of space. Minus 1 into minus 4. First row, second column. Next, minus 1 into 3. Next, 2 into second row, first column. 2 into 1. 2 into minus 4. 2 into 3. Second row with all the 3 columns. Next, third row with all the 3 columns. 1 into 1 over. Third row, first column multiplication got over. Next, 1 into minus 4. Next, 1 into 3. Simplify the right hand side matrix. This is minus 1, 4, minus 3. Write left hand side as it is. 2, minus 8, 6. 1, minus 4, 3. Simplify the right hand side matrix. Minus 1 into 1 is minus 1. Minus 1 into minus 4 is plus 4. Minus 1 into 3 is minus 3. 2 into 1 is 2. Minus 8, 6, 1, minus 4, 3. These two are equal. These two matrices are equal. Hence, AB whole transpose is equal to B transpose A transpose. Therefore, AB whole transpose is B transpose A transpose. Homework problem, say verify AB whole transpose is equal to B transpose A transpose, where A is 0, 1, 2. B is 1, 5, 7. Homework. Try the same type of problem. This is a homework problem. Try this one. Again, 5 marks question. Take on next problem. If matrix A is equal to cos alpha, sin alpha, cos alpha, sin alpha, minus sin alpha, cos alpha, verify A into A transpose is equal to I. Verify A into A transpose is equal to I. That means you have to show that A into A transpose, not A into A transpose, A transpose into E. Verify A transpose into A is equal to I. Change that one. A transpose into A is equal to I. A is given. I need A transpose. How do we calculate A transpose? By interchanging of rows and columns. A transpose is, write rows as column, column as row. Cos alpha, sin alpha, minus sin alpha, cos alpha. Cos alpha minus sin alpha, cos alpha. Next, left hand side, we have to verify. Left hand side is A transpose into A. After simplifying, I should get an identity matrix I, 2 cross 2 identity matrix, which is equal to A transpose, just now we have calculated, cos alpha minus sin alpha, cos alpha. This is A transpose into, A transpose is this one, into A is cos alpha, sin alpha, minus sin alpha, cos alpha. Multiply these two matrices. First row, first column. First row, second column, write it in first row. Second row, first column. Second row, second column. Therefore, A transpose into A is, multiply first row, first column. Cos alpha into cos alpha. Cos alpha into cos alpha is cos square alpha. Cos alpha into cos alpha is cos square alpha. Plus in between sin is plus. Minus sin alpha into minus sin alpha is plus sin square alpha. Cos alpha into cos alpha is cos square, plus minus sin alpha into minus sin alpha is sin square alpha. Next, first row, second column. Cos alpha into sin alpha is cos alpha sin alpha, plus minus sin alpha into cos alpha is minus sin alpha cos alpha. Cos alpha into sin is cos alpha sin alpha, minus sin alpha into cos alpha is minus sin alpha cos alpha. First row, first column, first row, second column, got over. You should write it in first row. Next, multiplication of second row with first column. Multiplication of second row with first column. Sin alpha cos alpha plus into minus cos alpha sin alpha. Sin alpha cos alpha minus cos alpha sin alpha. Next, second row, second column. Sin alpha into sin alpha is sin square alpha. In between sin is plus. Cos alpha into cos alpha is cos square alpha. Sin square alpha plus cos square alpha is 1. Therefore, A transpose into A is equal to cos square plus sin square is 1. Cos alpha sin alpha minus, this is plus, this is minus, get cancelled. Plus minus get cancelled. Again sin square plus cos square is 1. It is nothing but an identity matrix I. Therefore, A transpose into A is equal to I. Verify A transpose into A is equal to. Hence verified. Next question. Show that matrix A is equal to 1 minus 1 5 minus 1 2 1 5 1 5 1 3 5 1 3 is a symmetric matrix. Show that A is a symmetric matrix. Is a symmetric matrix. Show that A is a symmetric matrix. Tell me what is the definition of symmetric? A transpose must be equal to A. Calculate A transpose, show that is equal to A. A transpose is interchanging of rows and columns. Write rows as column, column as row. Write rows as column, column as rows. This is nothing but the matrix A only. These two are same. It is nothing but A. Therefore, A transpose is A. Therefore, A is a symmetric matrix. Therefore, A is a symmetric matrix. Here, A transpose, this is nothing but the matrix A only. A transpose is A. Therefore, A is a symmetric matrix. Next, show that. Next problem, show that A is equal to 0, 1, minus 1, minus 1, 0, 1, 1, minus 1, 0 is a skew symmetric matrix. Is a skew symmetric matrix. Is a skew symmetric matrix. A is given, calculate A transpose. Definition of skew symmetric is A transpose must be equal to minus A. A transpose must be equal to minus A. A is given, calculate A transpose by interchanging of rows and columns. 0, 1, minus 1. Write rows as column, column as row. Minus 1, 0, 1. 1, minus 1, 0. To get minus A, you take out minus common factor from each element. Take out minus common factor from each element. 0. We have taken minus common factor, it becomes plus 1. Here we have taken minus common factor, it becomes minus 1. Minus common factor, minus 1, 0. Minus common factor, plus 1, 1, minus 1, 0. From all the elements you take minus. Minus into 0 is 0. Minus into 1 is minus 1. Minus into minus 1 plus 1. Minus into minus plus 1, 0. Minus into 1 is minus 1. Minus into 1 is minus 1. Minus into minus plus 1, 0. Therefore, A transpose is equal to, write minus sign. This is nothing but the matrix A. This matrix is nothing but the matrix A. A transpose is minus A. Therefore, A is a skew symmetric matrix. Therefore, A is a skew symmetric matrix. Symmetric means A transpose is equal to A. Skew symmetric is A transpose is equal to minus A. We have shown that A transpose is minus A. Therefore, A is a skew symmetric matrix. Next, express the following matrices. Express, heading, express the following. Express the following matrices. Express the following matrices as the sum, SUM, sum of matrices as the sum of a symmetric, and a skew symmetric matrix, and a skew symmetric matrix. Skew symmetric matrices. Express the following matrices as sum of symmetric and skew symmetric matrices. See, we have shown that in theorem number 1, half into A plus A transpose is a symmetric matrix. Half into A minus A transpose is a skew symmetric matrix. Here in this problem, we have to express the matrix A as sum of symmetric and skew symmetric matrix. That is, we have to show that A is equal to, symmetric is half into A plus A transpose plus sum is plus half into A minus A transpose. We have to show that A is equal to this one. You write. We have to show that A is equal to, right, please write. We have to show that A is equal to half into A plus A transpose. We have to show that A is equal to half into A plus A transpose plus half into A minus A transpose. First question is A is equal to, first problem, A is equal to 3, 5, 1 minus 1. 3, 5, 1 minus 1. A is given, calculate A transpose. Therefore, A transpose is interchanging of rows and columns. 3, 5, 1 minus 1. Calculate A transpose. First I am going to calculate A plus A transpose, then A minus A transpose. A plus A transpose is, add these two matrices. This is A, this is A transpose. Add the corresponding elements. 3 plus 3, this plus this. 5 plus 1, 1 plus 5, minus 1 minus 1. Add the corresponding elements of the two matrices. Add the corresponding elements of the two matrices. This is nothing but 3 plus 3 is 6, 5 plus 1 is 6, 1 plus 5 is 6, this is minus 2. Next I have to calculate half into A plus A transpose. Next I have to calculate half into A plus A transpose. Half into A plus A transpose means this is A plus A transpose. Multiply each element by 1 by 2 or divide by 2 each element. Divide by 2. This is 6 by 2. 6 by 2. 6 by 2 minus 2 by 2. This is the scalar multiplication of the matrix. Multiply each element by 1 by 2 or divide by 2. 6 by 2 is 3. Again 6 by 2 is 3. 3 minus 1. Equation number 1. Half into A plus A transpose is 3, 3, 3 minus 2. Minus 1. Next you have to calculate half into A minus A transpose. We have calculate A minus A transpose. This is A transpose. Subtract A transpose from A. This is 3 minus 3. We are subtracting. Minus 3 minus 3. 5 minus 1. Next 1 minus 5. Minus 1 plus 1. This is nothing but 3 minus 3 is 0. 5 minus 1 is 4. 1 minus 5 minus 4. This is 0. 0, 4 minus 4, 0. Next you have to calculate half into A minus A transpose. This is A minus A transpose. Multiply each element by 1 by 2 or divide by 2. 0 by 2. 4 by 2. Minus 4 by 2. 0 by 2. Divide each element by 2 or multiply by 1 by 2. This is equal to 0. 4 by 2 is 2. Minus 2. 0. Equation number 2. See here, I have to show that half into A plus A transpose plus half into A minus A transpose must be equal to A. Therefore, consider add 1 into. Add 1 into. Left hand side is half into A plus A transpose. Left hand side of 2 is half into A minus A transpose. Is equal to right hand side you have to add these two. This is 3. 3 minus 1. This is half into A plus A transpose plus half into A minus A transpose 0. 2 minus 2 0. Right hand side you have to add the two matrices by adding the corresponding elements. Therefore, half into A plus A transpose plus half into A minus A transpose. We are adding the two matrices. Add the corresponding elements. 3 plus 0. 3 plus 2. 3 minus 2 minus 1 plus 0. Add the corresponding elements. This is half into A plus A transpose plus half into A minus A transpose is equal to, simplify. 3 plus 0 is 3. 3 plus 2 is 5. 3 minus 2 is 1. Minus 1. This is nothing but matrix A. That matrix is nothing but A. Therefore, half into A plus A transpose plus half into A minus A transpose. This is nothing but the matrix A. This is the matrix A. That is, we have expressed the square matrix A as sum of symmetric and skew symmetric matrix. We have shown that half into A plus A transpose plus half into A minus A transpose is equal to A. That means we have expressed A as sum of symmetric and skew symmetric. This is symmetric. This is skew symmetric. Half into A plus A transpose is symmetric. Half into A minus A transpose is skew symmetric. Take the next problem. A is equal to 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3. Express this as sum of symmetric and skew symmetric matrix. First you have to calculate A transpose by interchanging of. A transpose is interchanging of rows and columns. 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3. Calculate A transpose. Next you calculate A plus A transpose. Add the corresponding elements. 6 plus 6. 6 plus 6. Minus 2 plus minus 2. 2 plus 2. Add the corresponding elements. This plus this. Minus 2 minus 2. 2 plus 2. Next, minus 2, minus 2, 3 plus 3, minus 1, minus 1, add the corresponding elements, 2 plus 2, minus 1, minus 1, 3 plus 3, which is nothing but 12, minus 4, 4, minus 4, 6, minus 2, 4, minus 2, 6. A plus A transpose. Next you have to calculate A minus A, half into A plus A transpose. Next you have to calculate half into A plus A transpose. That is, this is A plus A transpose. Divide each element by 2 or multiply by 1 by 2. This is 12 by 2 minus 4 by 2. 4 by 2. Minus 4 by 2. 6 by 2 minus 2 by 2. Next is 4 by 2 minus 2 by 2. 6 by 2. Simplify. 12 by 2 is 6 minus 2 plus 2 minus 2 3 minus 1, 2, minus 1, 3. This is equation number 1. Calculate next A minus A transpose. Subtract A transpose from A. 6 minus 6. Minus 2 minus 2. Subtract. Minus 2 minus of minus 2 becomes plus 2. 2 minus 2. Next, minus 2 minus of minus 2 plus 2. 3 minus 3. Minus 1 minus of minus 1 plus 1. 2 minus 2. Next is minus 1 minus of minus 1 is plus 1. 3 minus 3, which is nothing but 0, 0, 0, 0, 0, 0, 0, 0, 0. Therefore, half into A minus A transpose. Since all the elements in the matrix are 0, if you multiply by half, you will get 0 only. This is equation number 2. You have to calculate first A plus A transpose, then half into A plus A transpose, equation 1. Next, A minus A transpose, half into A minus A transpose, equation number 2. Next, you have to add 1 and 2. While adding, you have to add the left hand side separately, right hand side separately. Half into A plus A transpose plus half into A minus A transpose. This is half into A plus A transpose. Half into A plus A transpose. 6 minus 2, 2. minus 2, 3, minus 1. 2, minus 1, 3. Plus half into A minus A transpose plus 0, 0, 0, 0, 0, 0, 0, 0, 0. Now right hand side you have to add the corresponding elements. This is nothing but 6 plus 0, minus 2 plus 0, 2 plus 0. Add the corresponding elements of the two matrix. Minus 2 plus 0, 3 plus 0, minus 1 plus 0, 2 plus 0, minus 1 plus 0, 3 plus 0. Add the corresponding elements. Therefore, half into A plus A transpose plus half into A minus A transpose is equal to, simplify, 6 plus 0 is 6, minus 2 plus 2, minus 2, 3, minus 1, 2, minus 1, 3. This is nothing but the matrix A. Therefore, half into A plus A transpose plus half into A minus A transpose is equal to A. Therefore, we have expressed A as sum of symmetric and skew symmetric matrix. Therefore, A is equal to half into A plus A transpose plus half into A minus A transpose. Next homework problem is homework problem. A is two questions. A is 1 5 minus 1 2. Second question, A is 3 3 minus 1, 3 3 minus 1, 3 3 minus 1, minus 2, 1, minus 4, minus 5, 2. Two problems homework. One is 2 cross 2, another is 3 cross 3. Next side reading, elementary transformation. Side reading, elementary transformation. Elementary transformation, or it is also called as operation. Elementary operation. Transformation or operation both are same. Elementary transformation of a matrix. Of a matrix. Side reading is elementary transformation or elementary operation of a matrix. See, there are three elementary operations are there. First one is interchanging of rows and columns. Interchanging of rows and columns. First operation is interchanging of rows and columns. That is, we can interchange R1 by R2. We can interchange row 1 to row 2. Or column 1 is, we can interchange C1 and C2. First column and second column we can interchange. Second one is, we can multiply. We can multiply any row or any column. Any row or any column by a constant, by a scalar, by a scalar. K. K is a constant or it is a scalar. Scalar or constant both are same. That is, R1 is nothing but we can multiply R2 by scalar K. Or C1 is replaced by K into C2. We can multiply any row or column by a scalar K. This is R1, not R2. C1. We can multiply any row or any column by a scalar K. Third one is take note. The addition of the elements of any row. The elements of any row. Elements of any row or column the corresponding elements the corresponding elements of other row or column of any other row or column by a non-zero real number. By a non-zero number. That means R1 plus sum of the elements of any row or column of the corresponding elements of other row or column. That is, where K is any non-zero number R2. We are multiplying R2 by a non-zero number and we can add to equation number 1. Or column wise C1 plus K into C2. Multiply any other column by K, add to C1. Multiply any constant, any non-zero real number for R2 and add to R1. These three are the elementary operation. Using this elementary operation, we'll go for problem. Two theorems are there, one definition and two theorems are there. After completing those, we'll go for a problem. We'll continue afterwards after break of 20 minutes. Now it is 7:50. We will come back by 7:35. 7:50.
7:40 के लॉगिन आएगी.
Please take on the problem. Take on the problem. Using elementary transformation. Using elementary transformation. Transformation is also called as operation. Using elementary operation, find the inverse of the following matrices. Using elementary transformation or elementary operation, find the inverse of the following matrices. In the examination, there will be one question for 3 marks, finding the inverse using elementary operation. It is a compulsory question for 3 marks, or if they don't ask this type of problem, they ask
Show that every matrix can be expressed as sum of symmetric and skew symmetric matrices. Previous problem I have done that may ask for 3 marks, or using elementary operation find the inverse. Choice between these two. Either they will ask that question or finding the inverse. First question is A is equal to 1 minus 1 2 3. We have to find the inverse of this matrix using elementary transformation or elementary operation.
See, in multiplication of matrices, in properties of multiplication of matrices, the third property is A into I is equal to I into A is equal to E. This property is given.
Multiplication of matrices satisfy identity law.
A into I can be written as I into A can be written as A. That means either A into I is equal to A or I into A is equal to E. The meaning of this statement is A into I is equal to A or I into A is equal to E. I am using this property while doing the problem to find the inverse. And one more property, fourth. Multiplication of matrices satisfies inverse law. A into A inverse is equal to A inverse into A is equal to I. That means I can be written as A into A inverse or I can be written as A inverse into A. That is the meaning of the fourth property.
I am using these two in this problem. I am using these two properties of multiplication of matrices in this problem.
We can write matrix A as I into E. I into A. Writing this equation carry 1 mark. It is a 3 marks question. Writing just A is equal to I into E. Just write A is equal to I into A carries 1 marks. Left hand side, you replace A by that matrix. A is 1 minus 1 2 3 is equal to I is, since it is a 2 cross 2 matrix, I is 1 0 0 1 into, write A as it is. Don't replace for A by this matrix because I am expressing A inverse into A is equal to I. That means I am making the left hand side matrix to be I. This A inverse into A. I will try to write in this form. I is equal to A inverse into A. Therefore, I am not replacing A by that matrix. First, I will make the left hand side matrix to be identity matrix. Identity matrix is 1 0 0 1. Identity matrix is 1 0 0 1. Already 1 is there. Nothing to worry. Next, I have to make the second element to be 0 using row operation. See here, to make this element to be 0, to make second element to be 0, I have to make this element to be 2. 2 minus 2 becomes 0. I have to make this element to be 0. To make this element to be 0, I have to make first element to be 2. Therefore, calculate 2R1 in the previous step. Calculate 2R1. 2R1 means multiply R1 by 2. Right here, 2 into 1 is 2. Calculate 2R1. To make this element to be 0, I have to make this also to be 2. After subtracting, this becomes 0. I have to make this element to be 2. Therefore, multiply, this is R1. This is R2. Multiply R1 by 2. 2R1. 2 into 1 is 2. 2 into minus 1 is minus 2. 2 into 1 is 2. 2 into 0 is 0. In the previous step, you have to calculate 2R1. calculate 2R1 in the previous step. That means multiplying R1 by 2. This is R1, this is R2. 2 into 1 is 2, 2 into minus 1 is minus 2, 2 into 1 is 2, 2 into 0. Now I have to make this element to be 0. Already 1 is there. I have to make this element to be 0. Left hand side you should write the operation, draw operation. I have to make this element to be 2, mean this is R2. R2 dash. R2 dash represent next step new second row. Dash represents new row. R2 dashing, this is R2. This is R2 minus 2R1. 2R1 is this one. 2R1 minus 2R1. To make this element to be 2 to be 0, I have to do operation for R2. R2 dash is R2 minus 2R1. Because R2 is 2, minus 2R1 is 2. In between sign is minus. 2 minus 2 becomes 0 here. R2 dash, new second row. R2 minus 2R1 I have calculated. 2 minus 2 is 0. If you have any doubt, you please ask me. If you have any doubt. To make this element to be 0, I have to make this to be 2. To make this to be 2, I have to multiply R1 by 2, calculate 2R1 in the previous step. Next row operation is R2 dash. Dash represents next step new second row. R2 minus 2R1. This minus this. 2 minus 2 is 0. I hope all of you are following. If you have any doubt, you please ask me. R2 dash is R2 minus 2R1. 2 minus 2 is 0. Next 3 minus of minus 2. This is 3 plus 2, that is nothing but 5. You have to write it in R2 only, not other row. This is 5. This minus of this, 3 minus of minus 2 is plus 5, is equal to, right hand side matrix also you have to do this one. 0, R2 is 0, minus 2R1, this is minus 2. 0 minus 2. Next 1 minus 0 is 1. Close the bracket, write A as it is. See, in this step, I change only R2. R2 dash means in the next step, new second row. R2 dash is R2 minus 2R1. This minus this. 2 minus 2 is 0. 3 minus of minus 2 plus 5. 0 minus 2 is minus 2. 1 minus 0 is 1. Here I have not touched R1 here. In this step, write R1 as it is. Write R1 as it is. 1 minus 1, 1, 0. Any doubt in this step, please tell me. I will once again explain. Any doubt? Students, you have any doubt? First, you have to make 1. Next, you have to make 0. Next, you have to make this one, not this 0 first. 1, 0, 1, 0. In this order only, you have to make the left hand side matrix as an identity matrix. First, you make 1. Next, you make 0. Next, you make 1. Next, you make 0. I got 1 and 0. Next, I have to make 1. Please remember, to make 1. To make 1, rule is either multiplication or division. To make 1, either multiplication or division. To make 0. To make 0, either addition or subtraction. To make 0, you have to do either addition or subtraction. To make 1, either multiplication or division. I have made 1. I have made 0. Next, I have to make this to be 1. To make this one, divide R2 by 5. 5 by 5 becomes 1. Therefore, in the next step, I have made 1. I have made 0. Next, I have to make this to be 1. Therefore, divide R2 dash is. Divide R2 by 5. This is R1, this is R2. To make this to be 1, divide R2 by 5. Write first one as it is. I change only R2. Here also R2. Write R1 as it is. 1 minus 1. 1, 0 into E. Anybody has any doubt in the previous step, please tell me. I will once again explain. Any doubt? Next, R2 dash is R2 by 5. This is R2, this is R1. Divide R2 by 5. 0 by 5 is 0. 5 by 5 is 1. 0 by 5 is 0. 5 by 5 is 1. Next, you have to divide by 5. Minus 2 by 5. Divide by 5. 1 by 5. See here, just if you do this operation, it carries 1 mark. Just first operation, it carries 1 mark. And if you are doing other problem, if you don't write these operations, you will get 0. Writing the operations are very, very important. In the left hand side, I made first element to be 1, second element to be 0, third element to be 1. Next, I have to make this element to be 0. 1, 0, 1, 0. I have made 1, 0, 1. Next, I have to make this to be 0. This to be 0 means it is a row operation for R1. R1 dash is. To make this to be 0, you have to add R1 and R2, write it in R1. R1 dash is. R1 dash is, if you add R1 and R2, it becomes 0. It must be written in R1. If you add these two, it becomes 0. Write it in R1, not in R2. To make this element to be 0, 1, 0, 1, 0. To make this element to be 0, in R1, add R1 and R2, it becomes 0. R1 dash is R1 plus R2. This is R1, this is R2. 1 plus 0 is 1. 1 plus 0, R1 plus R2. 1 plus 0 is 1, minus 1 plus 0 is 0. Don't write R2 dash. This element is in R1. R1 dash is R1 plus R2. Next, add these two. 1 minus 2 by 5. LCM is 5. 5 minus 2. This is nothing but 3 by 5. This is nothing but 3 by 5. Next, you have to add these two 1 by 5. I have not touched the R2 here. Write R2 as it is. 1, 0, minus 2 by 5, 1 by 5. I have not touched R2, write R2 as it is. See here, this is A inverse. This is the inverse of A. I have to calculate A inverse is what? Now, left hand side, it is nothing but I is equal to right hand side A is there already. It should happen only when I must be equal to A into A inverse. Therefore, this matrix is nothing but A inverse. This matrix is nothing but A inverse because I is equal to A inverse into A. Therefore, answer A inverse is. Write that matrix. After getting this step, it is of the form. Please write, it is of the form I is equal to A inverse into A. Therefore, A inverse is 3 by 5, 1 by 5, minus 2 by 5, 1 by 5. This is the final answer. This symbol is nothing but inverse of A inverse. Final answer, getting this step 1 mark. It is a 3 marks question.